Good morning, good afternoon, good evening, whenever you're watching this. Today is a good day because we get to do calculus. So let's do this. If you turn to daily lessons, page 124, you're going to notice that this page looks very familiar to you. It's because we already did it as the Unit 4 test review. So we're actually going to skip right past 124, right past 125. If you want to know, how do I do any of these things? This doesn't look familiar to me. You can go back to the Unit 4 test review video. But we're going to go to this page. So daily lessons 126 and 127. So the first thing we're going to do is start off with some review. So in here it says consider the cubic function. So we've got this function. This is f of x. Great. To answer the following questions. We're going to use this the whole way down through the page. Determine the intervals where f is increasing or decreasing. Okay, if f is increasing, what does that mean about f prime? F prime is positive. If f prime is if f is decreasing, it means f prime is negative. So what we're going to do is we're going to find the places where the derivative is 0, meaning it's neither negative nor positive, and then make a chart, figure out where is the derivative positive, where is it negative. So first thing you need to do is take the derivative. So f prime of x is negative 3x squared minus 12x minus 9. I want to set this equal to 0. When I set this equal to 0, I'm actually going to factor out this negative 3. Because now I can factor this more easily and figure out what these values of x are that make this 0. That means my 0 for the derivative, f prime, are going to be x equals negative 3 and x equals negative 1. If I substitute, or if I set negative 3 equal to 0, I don't get anything. If it was negative 3x, then you'd have one more that said x equals 0. But it's just negative 3. I'm going to make a chart. Negative infinity to my first 0, which is negative 3. I'm going negative 3 to negative 1, negative 1 to infinity. From negative infinity to negative 3, pick your favorite number. So mine is negative 400. I don't know. I would have negative 400, or negative 3, which would be negative, times negative 400 plus 3 would still be negative, times negative 400 plus 1, still negative. Negative times negative is positive, times negative is negative. Over here from negative 3 to negative 1, let's pick, I don't know, I'm picking negative 2. This would be negative. Negative 2 plus 3 is positive. Negative 2 plus 1 is negative. Negative times positive is still negative, times negative is positive. Then pick your favorite number out here. 5,007. Sure, we picked the same thing. We have so much in common. Negative. This would be positive, and then positive. Negative, positive, positive. Multiply them together, you would get negative. Okay, which means that f would be decreasing, increasing, decreasing. And if we wanted to, we could even figure out max and mins. Decreasing to increasing would be a relative max. Increasing, decreasing is a relative, wait, did I say that wrong? Decreasing to increasing, relative min. Increasing to decreasing, relative max. Okay, then I want to say, it says determine where f is increasing or decreasing. So I'm going to say f is increasing on the interval negative 3 to negative 1. And the reason is as f prime is greater than 0. And then do decreasing. F is decreasing on the intervals negative infinity, negative 3, and negative 1 to infinity. And the reason is f prime is less than 0. Easy peasy lemon squeezy. Relative extrema, you could also say local extrema or relative minima or maxima, any of those things. The coordinates of relative extrema would be, oh, and it says coordinates, so we need the x and the y value. So I know that f has a relative minimum at, and I know my x value here was negative 3. So f of negative 3 equals, I'm going to figure that out in a second. So I need the y value yet. And the reason is f prime changes from negative to positive. I'll move my hand in a second. F has a relative max at f negative 1. I'm going to say as f prime changes from positive to negative. You guys are getting really good at that. Okay, so f of negative 3. F of negative 3, that's the one that we need to find first. So if I go up to this first function, I actually already put this in here in y1. So I'm going to use it, and I'm going to do second calc, and I'm going to find the value, meaning just the function value, and it comes up with x. So I'm going to say x is equal to negative 1, and I can see y is 6. So that was down here. Do the same thing. So second, calculate. I'm going to go down to 0 at negative 3. Push enter, and I can see y is 2. So I'm looking down here. Okay, so all old stuff so far. You're like, great, we're 7 minutes in, we haven't learned anything new. I really want to emphasize to you, f is increasing, that means f prime is positive, decreasing, that means f prime is negative, and the places where relative extrema happen. Okay, so if we're sketching an accurate graph, so over here, if I graph this, because I already did, I went to y equals, it's a little bit hard to see, maybe you can see it that way a little bit. I went to y equals, I put in the function as it was given, and then what I did was I changed my window, and I put my x min over here at negative 7, my x max at 5, and then I did the same thing, my y min the whole way down at negative 14, because that was what was on this paper graph, and my y max at 8. Then I can graph this. But that's not quite enough. The next thing I need to do is go into my table. So if I second, and then table, here I'll put it over here so you can see again, second table. If yours is starting at something weird, like I can even see mine's a little bit crazy right now, you can always change your table set. I've gotten a lot of questions on that lately. Second, and then table set. This will tell you what number you want to start at, often 0. This tells you what you want to go up and down by. Okay, so I'm going to pick a couple points on here. I did negative 1, 6, negative 2, 4. You can see negative 2, 4, negative 3, 2. It came from here. Negative 4, 6. So I picked some points in the graph, and then I actually picked another one. If I went to 1, I got 1, negative 14. You used that one? Okay. And so I'm going to turn back on this plate again. Sorry, hard to see for a second. This is how I sketch an accurate graph, though. I can see something like this is happening. And I can't really tell what's going on here. If I want to, this will actually just keep going. But and it says on the interval from negative 4 to 1, so we're good. We don't even need this arrow because we're just sketching from negative 4 to positive 1. Okay, the next question says identify an absolute maximum. So this is different from the things we've done so far because we've only done relative maximum. Relative maximums occur like if you're, let's say, relatively tall, meaning in your family, maybe everyone in your family is 5 feet tall, but you're 5'3". So in your family, you are the tallest. You are like the relative maximum. But if you go out into like the greater community, 5'3" might not be the tallest person in the room. In fact, it's probably not. Maybe there's somebody even taller. Or if you're going into the world, there might be somebody even taller than that, which there probably will be. But there's going to be one tallest person in the world, and that is going to be the absolute maximum. We can also just do this on an interval. So if I'm saying the absolute max on this interval from -4 to 1, I'm looking and seeing what is the highest y value. Anytime we're talking about the maximum value, it's talking about the y value. So absolute maximum from -4, ooh, this one just says to -1, so be careful. -4 to -1. I can see the highest y value is up here at 6. The absolute minimum is going to be from -4 to -1. So from here to here, what do you think it is? That's right, it's going to be 2, because that's my y value. It's going to happen right here. Absolute maximum, this is from -4 to 1. So the whole way from here over here, what's the absolute maximum going to be? Again, this function value, the y value of 6. Absolute minimum, now I'm going from -4 the whole way to 1, and I can see this minimum is going to be down here at -14. You can see when it occurs, like I'm going to say 6, which occurs at x equals -4 and x equals -1. That's okay to have more than one. This 2, which occurred at x equals -3. I should have also done this in the very beginning, but this graph is the graph of f. That's why I can do it like this, where I'm just looking and seeing what is the maximum, what is the smallest number, here too, the minimum. Absolute maximum on this interval, so it's just 6 again, and it's at those same places. So at x equals -4, x equals -1, and this -14 happens when at x equals 1. But the actual maximum value or minimum value for absolute is going to always be the y value, so the function value. Let's do some more. This brings us to a theorem. What? It's called the extreme value theorem. If f is continuous, so meaning there's no holes, gaps, the limit from the left equals every point the function is defined. The limit from the left is equal to limit from the right for every point, and the function value equals the limit, meaning no holes, there's no jumps, there's nothing crazy going on, no vertical asymptotes. So if f is continuous on this closed interval from a to b, then f has both a maximum and a minimum on that interval, meaning there will be a high number and a low number. Even if we're talking about a horizontal line, it's just the maximum value and the minimum value would actually be the exact same. So this theorem doesn't really tell me too much, but there's some extra things that we can know from this. So even though the extreme value theorem just says it will have a maximum and a minimum, which is not too much, I'm going to tell you that all of these max and min points occur at endpoints or critical values. What I mean by that is where the derivative, critical values, you've seen this term a couple times, but I know that it hasn't been super defined for you yet. Critical values are where the derivative equals 0 or does not exist. These are the numbers that we put in the chart. This is what will happen. So at critical values or endpoints. So what I want to do now is I want to say determine the absolute extrema. So this is more just extra. So always check endpoints or critical values. I should even put and, because this is what we want to check and see what has the absolute max, what's the absolute min. Okay, this says absolute extreme values, and it's only on this given interval. So this one says -1 to 3. Before I can do anything else, I need to check, is this function continuous? Will it have a, am I guaranteed to have extrema? So if I look on this one, this is a polynomial, so yes, f is continuous, and that's okay. So because nothing crazy is going on. In this one, anytime I see sign written like that. It looks cool, but I want to rewrite it so I know exactly what it's talking about. This would be sine of x squared plus cosine of x. Sine of x and cosine of x are both periodic functions. They both are continuous, so we're good. Here, is this one good? We've got something to the 2/3 power, so I'm going to square anything I put in here. It's going to make a positive cube root. Looks good to me. This one is also continuous. How about this one? You can't take the natural log of a negative number. So x squared minus 4 has to be greater than 0. And you can't take the natural log of 0 either. The natural log of 1 is 0. So if I do x squared has to be greater than 4, that means x, if you square root both sides, x must be greater than, in this case, you can say is greater than 2 if you just took the square root of both sides. Oh, sorry, almost in my hand. There we go. Or you can say x squared has to be less than negative 4. It's rules of inequalities from a long, long time ago. And then this one, I can't actually take the square root of this one. Oh my gosh, my husband just scared me a whole lot. He is outside the window right now, freaked me out. He was making sure he didn't interrupt the video, and he definitely did. Okay, so I've got x squared is equal to, or is less than negative 4. And my dog's barking at him. Awesome. Okay, x squared is less than negative 4, which that doesn't make sense because you can't take the square root of both sides. So this doesn't work. We've got x is greater than 2. Hey, that means on the interval, if I tried to substitute a negative 1 in here, negative 1 squared, I would get 1 minus 4 would be negative 3. Not cool. So h of x is not continuous. Therefore, I can say extreme value theorem cannot be applied, or you can say this function is not guaranteed to have absolute extrema. Okay, so let's try this one. And I don't have to write out that all of these are continuous, but now I can go through and I'm going to figure these out. What are they? Okay, so what I want to do every time is if I want to know what the extreme values are, and I said that they can occur, you have to check endpoints or critical values. That means I want to try f of negative 1, because that's my endpoint, f of 3, and I also want to choose f of any critical values. So that means I need to find my derivative, set it equal to 0, this one gets annoying really quickly because what's going to happen here is that you're going to try to factor this and you're like, I can't do it. And so you can do a couple of things on this one. Let's pull out the quadratic formula. So if I say negative b, so negative 4 plus or minus square root, b squared would be 16 minus 4ac over 2a, or you can put this in your calculator, set it equal to 0, find the zeros, and then make sure that you're using as many decimal places as possible until the final n, because this x value, whatever we get here, is not going to be your final answer. So if you're doing it that way, I think, what did I put in here? Oh yeah, negative b, hold on. Oh, I reduced it on there. Okay, so I think you could keep going with this and be like, this is 4 plus or minus 4 times 3 minus 3, or 4 times 3 negative 3. This is 16 minus a negative 36, or I can say plus 36 over 6, and I can keep going with that. I'm sorry, my dog's going crazy. if I keep going, by the way, this is 2 plus or minus 16 plus 36. And then I can actually put this in here. So I would have f of 2 plus square root of 52 over 6, 2 minus square root of 52 over 6. And I could substitute this in here. If you were like, Miss DeWald, you lost me, I'm not cool with what you were just doing, you could have just taken this and said, well, I want y equals, and I'm going to turn this off here. I'll just delete it. You could have put in 3x squared minus 4x minus 3. And then you do zeros, so this is only on the interval from -1 to 3. So I'm going to go window, -1 to +3. I find the zeros. Second, calculate 0. If I go left bound, I'm going to the left of that 0. I'm sorry, this is hard to see. Is that better? So I'm going left of that 0, right of that 0. I'm going to push enter. And so then you can say f of -5.351838. Here, I'll put this in here. -0.5351838. And you also want to put f of second, calculate. $1.868 5171. You're going to go back up to this original function, and this seems like it's cheating a little bit, because why would we even use this in the first place if we had a calculator and we can just find the min and maxes of this? We're just practicing, so you know that this actually works. But if I go back up to this original function, the original function was x cubed minus 2x squared minus 3x minus 2. If I graph this, I can see right now that if this were my original function, my absolute maximum could happen maybe here, maybe over here. It's a little bit hard to tell right now. But if I see, if I say second, calculate, and I go down and I want the value at -1, make sure my window's in the right place. Yep, we're good. If I want second, calculate the value at -1. Do you see how the goes the whole way over here? This is my endpoint, where y is -2. If I try the other endpoint, so my value at 3, I also get -2. And I'm hoping if we did this correctly, this should be the absolute, the relative extrema. So the relative max, the relative min should be these other points that we got. So second, calculate value at -0.5351838, or you could have gotten the value from the quadratic formula. Hey, look, that's my maximum here. This one was -1.120. You can round or truncate. I just truncated, meaning I cut off everything after this. I'm not going to use this number anymore, which is why I only did 3 places after the decimal. And then the other one, second, calculate value 1.8685171, and I get this y value of -8.064, and I could say 605, or I could have rounded this one. Okay, so I did all of this work, and it says determine the absolute extrema. What I do now that I have these endpoints and where the derivative is 0, I look at the highest number and the lowest number. This is going to be my absolute minimum. For my absolute max, I picked my highest number. This one's not very high, but this is going to be my absolute maximum. Ta-da! We did it. Okay, let's do another one. So in this one, we want g prime of x. So we want g prime of x. And then take the derivative. Wow. 2. Leave the inside alone. Times the derivative of the inside. Plus the derivative of cosine. Oh, I should have said minus. It was minus sine of x. Or negative sine of x. I want to see where this is equal to 0. I'm definitely going to use my calculator here. Although I could factor out a sine. That wouldn't actually be too bad. Let's do that. If I factor out a sine of x here, I would get 2 cosine of x minus 1. I can set sine of x equal to 0. The places where sine of x is 0 between pi over 2 and 2 pi. When I think of sine, I think of this. Sine is 0. Sine of 0 is 0. Sine of pi is 0. Sine of 2 pi is 0. So I'm going to say x can be pi. 2 pi is already included on here. You could say x is 2 pi also, but that's also a relative, or I'm sorry, an endpoint. So we are going to be checking g of pi over 2, g of 2 pi. Now this means that we also need to check g of pi. And then we also need to be checking if anywhere this 2 cosine of x minus 1 equals 0. If you add 1 to both sides, I get 2 cosine of x equal to 1. Cosine of x is equal to 1/2. And then you think about this, is there anywhere where cosine of x is equal to 1/2? I immediately think of this triangle. So I've got 1, 2, this other side would be square root of 3. If this angle, what would this angle have to be? To be 1 over 2? Well, let's think about what that angle is. If this triangle, this would be pi over 6 up here, because that's the smallest angle. I know you can barely see it. I don't know why I made it so small. This would be pi over 3. So cosine of pi over 3 is 1/2, but that's not in that interval. So this is a lot of trig all of a sudden. I should say awesome students take calculus. Pi over 3 would work. So cosine of pi over 3 is 1/2. And I want this to be positive. Sine is positive here. Tangent is positive here. Cosine is positive here. I need to think about what with pi over 3 would be in this quadrant to make cosine positive still. Did you get it? Cosine of 5 pi over 3. So here we would put g of 5 pi over 3. And then we go back to this original function. And we'd say y equals, be careful how you put this in. I would have put it in parentheses first, sine of x squared plus cosine of x. And I'm going to change my window. So I've got pi over 2 to 2 pi. I realize you could just be following along with me and using this work, but really try to put these in on your own. It's going to help you. Okay, so here's my function. I'm going to change my y values a little bit still. Okay, so second calc, and I'm going to find the value at pi over 2. Oops, what did I do? Value, and I want pi over 2. What's happening? If I do my x-min, if I do pi over 2, I'm going to subtract a little bit off that, like 0.1, only because sometimes it doesn't let you calculate the value if you're right at the end, so you might need to take a little bit off of whatever the starting window is, but let me check. pi over 2. Oh, good. Yeah, that's what it is. So sometimes, I don't know why, the calculator's kind of finicky with that. But if it's not on your screen in some way, so I just changed my window by a little bit, like I subtracted 0.1 off of it on the left, and I get 1.570, or you could say 571. And that's not what I got before, so let me just check and make sure that it is in here right. Sine of x squared plus cosine of x I can calculate the value at pi over 2. Oh, that's why, silly me, pi over 2 is the 1.57 whatever. The y value is 1. Whew. There we go. Got this. And then if I want to do second, calculate the value at 2 pi. Again, it's not letting me do this. So if you see it says invalid dimensions or something like this, if I change my window and I change my x max to, it was 2 pi plus a little bit more, so I just put plus 0.1. I would also get 1. Second, calculate the value at pi. And then the last one, 5 pi over 3. $1.25. Got it. And then we say, what is our absolute min, absolute max? Our absolute min is the smallest number. Absolute max is the highest number. Okay, I've spent a lot of your time doing this. So just so you get the idea of what's going to happen in all of these. If you see the function is continuous and you want to know what the absolute extrema is, you're checking the endpoints. And where the derivative is 0. There might be more than one value. So you find the derivative. Wow, times the derivative of the inside would just be 1. This would be 2 over 3 x plus 2 to the 1/3 power. And in this one, you might be saying there's no place where the derivative is 0. You're correct, but you have to account for all critical values. So even the places where the denominator is 0 or the derivative does not exist. So in this case, if I set just the denominator equal to 0, oh, this should be 3 times. It doesn't matter. Divide by 3 on both sides, you get 0. Take the cube, or cube both sides. There you go. X is equal to -2. And then you substitute this back into the original function. -2 plus 2 is 0 to the 2/3 would be 0. 6 plus 2 is 8. If I take the cube root of 8, I get 2 squared is 4. 3 plus, or -3 plus 2 is -1. Square that, I get 1. Cubed root of that is still 1. If you want to compare these, this is my highest, also known as absolute maximum. The lowest is my absolute minimum. Extreme value theorem, you have to check the endpoints or where the derivative is 0 for all continuous functions. F will have both an absolute min and an absolute max, and it could be at more than one location. Thanks for working. Thanks for doing this. I appreciate you. Yeah, have a great day.